Hello, welcome to our video series on the practical electronics, and this time we continue our discussion with the prototyping the electronic circuit and its test and measurement. So what you see on your screen is a simple voltage divider circuit or a resistance divider circuit. So you see here I have a 5 volt DC voltage source and two resistors are connected in series. So if I see the end of the resistor R1, one end of resistor R1 is connected to the power supply and one end of R2 is connected to the ground basically. So I can also draw this circuit in this fashion. So I have like 5 volt here and there is a resistor R1 and then there is a resistor R2, and here you have a ground and this is your resistor R2. So in between I can take the output voltage or a voltage. So there is a current flowing through the resistor network is called as R. So the voltage that I will measure here is a voltage again. So this voltage is equal to VR2. With this voltage is with respect to ground, so therefore it is voltage drop across R2. There is a voltage drop across R1 also, and these voltage drops are there because as soon as you close the circuit there is a current called I flowing through the circuit. So this is the same circuit as drawn over here. So what we understand from here, we are going to create a hardware prototype for this circuit. So you see here there is a voltage V equal to 5 volt, R1 equal to R2, both are 10k, and therefore the total current I will be voltage divided by the total resistance, Ohm's law, which is V divided by R1 plus R2, 5 over 20k, that comes out to be 0.25 milliampere. So we want to measure this current, so it is like 250 microampere. Similarly, the voltage dropped across resistors R1 and R2 can be calculated through Ohm's law again. Product of resistance and the current is the voltage. So you have a 10k each and you multiplied that with the calculated current because it's a series connection. It is also called a series circuit. So because of the series connection, the current is same through both the resistors, which is 250 microampere, and equivalent, therefore the resultant voltage drops across the resistors are 2.5 volt each, which equates to the total supplied voltage from the voltage source. So this is the voltage that you supply, which is 5 volt, and that is equally divided into the series circuit consisting the resistors. So how to verify these calculations? So you can actually see that I have this circuit like we explained in our previous module, and from these 2 points, positive and the negative, I have selected the 5 volt voltage source that will come out, and with that I have connected red probe as a positive and the black or the brown one is the ground one. So here I have 10k value of resistor each. They are connected in series. As you can see that the resistors are connected in series right here, and the positive goes to the end of R2, one of the end of R2. This is your R2 and that is your R1. So the positive connects to the positive connects to the one end of resistor. Because it's a series, I can swap the position of the resistors also, it doesn't matter, and they are equal values. So I have connected one end of the resistance to the positive and another end of the resistance to the negative. So that is how the series connection is made, and the junction between the two resistors right over here, you see this is a short here, and in theory you have this voltage right over here, that is the voltage division or the voltage divider circuit, voltage divider junction. So we will measure the voltages at various points in this circuit. We will measure the current through the circuits, and the resistance values from the color code and from the previous video discussion we know both are 10k each. So what you need to do is that, let me show you the complete wire and the complete circuit so that you see everything right here, and the connections, let me check the connections, they are connected there. Now I bring this battery right over here, and this battery I'm going to connect to the jack here, the battery jack. And you see on the simple breadboard I am making the prototyping. So what you can see here, the battery has been connected, this LED is switched off, so I will switch it on, and the LED is now connected. So the first thing first, I would need a meter which can measure voltage, which can measure current, and which can measure resistance as well. So for example, when the circuit is on, I would try to measure the voltages and the currents in the circuit. So what I'm going to do here, I will just move this a bit. I will just take it little bit up so that you can see all portions of my experimental setup. And I have now this black probe and the red probe connected to the respective terminals on the meter. I am going to measure the DC voltage, so I switch the position of the meter to the DC voltage knob here. So with that said, you now see I have a setting of DC voltage measurement. It is going to measure I haven't selected the range, so I set it to auto, so it will measure the voltage based on the reading. It will automatically capture the reading. So what I am going to do, I am going to measure the voltage delivered by the regulated power supply first. So I will connect the probes right here in this position and see the voltage is 5 volt, which is correct. So now at these two nodes, these 2 points, I have a 5 volt. Now let us see if that voltage is being delivered to the circuit of resistances also. That is correct, 5 volt. Now voltage drop across one resistor is 2.5 volt. Remember, VR1 and VR2. So we are calculating VR1, which is matching to our theory. Next, I am going to measure the voltage across resistance 2.5 again, and the total voltage that we measured is 5 volt, and the total voltage that we calculated is again the 5 volt. Now what can I do? I need to measure the current into the circuit, and remember, if I measure the current or if I calculate the current through the circuit, that current is same as the current flowing through R1 and the R2 because of the series connections of this. What if I have told you that there is a voltage that we want to measure at this point of the circuit with respect to ground? So what I will do is that I will connect the one probe to the ground, which is right here, and I will see the junction right here, and it is 2.5 volt as expected. Now I am going to measure the current. So to measure the current, I will switch off this first, take it away, then I will see where I can measure the current. So to measure the currents, I need to open the loop. I need to break the loop from somewhere. So for example, if I open this wire right here, or I can place the meter here, or I can place the meter here. So because this is the current that is flowing through the loop. So what I'll do here, I draw the circuit like this. This is your voltage source, then you have a resistance, then you have a resistance, and let's say I want to place the current, or this is the current meter, positive, negative. This is your R1, this is your R2, and that's your ground connection, and this is your ammeter that is measuring the current. Okay, and that's your current. Okay, so what I need to do is that I need to break the loop and put a meter which will read the current. So at these 2 points, across these 2 points, or somewhere here also, I can break the loop and put the meter. So again, I have brought back the multimeter on screen. I have brought back the hardware experimental setup on screen, and before that I make the measurement. I want to ensure I have the multimeter setting to the current reading. So I want to read the current in milliampere or microampere. Remember, the current here is 0.25 milliampere. So either I can choose the milliampere or microampere. Let us set it to microampere and see if it can measure that 250 microamps current. So it is set to auto, so I should have a auto measurement for this one. I haven't switched on the board yet, so the circuit is switched off. So what I am going to do, I will just let's say break the loop, and then I will connect it somewhere, put it somewhere. So at this point and at this point I need to connect the meter. Remember, the sign of the current would be positive or negative based on the direction of the current flow in the circuit and the probes I will connect it. So what I'll do, I'll connect the positive here and the negative here, and we'll see if it measures the current. So let's switch on the hardware circuit. It is switched on, and I have putting the ammeter actually in the circuit, and see, it is measuring 254 microampere, pretty close to what we calculated. So you see, this is how you measure various currents and the voltages into the circuit. So I have positive probe to the positive terminal of the battery. I have negative probe of the meter to one of the end of the resistor. So that's it. So we have conducted this experiment successfully, where I have shown you how to make a prototype series circuit using resistors, how to measure various voltages and the current, and how to learn about the voltage division circuits. What about the power consumption of this circuit? Power consumption is the power delivered by the source and power consumed. That is the power conservation actually. The power delivered by the source is equal to the power consumed by the circuit. So the power consumption is done through the resistors, and the powers we have seen in the previous module how the power is calculated, and we verified that. So they are quarter watt resistors each. It means they can consume 250, and they can bear maximum 250 milliwatts of the power. So the total current that is flowing through each of the resistors multiplied by the current square flowing through, the square of the current flowing through them, is I square into R, is the power dissipation in each of the resistor, and that value should be less than the rating of the given by the manufacturer. So we have explained that in the previous video, and make sure that you can cross verify for yourself. That is an exercise for you. So hope you like this video, understood the basics about creating the simple prototyping circuits. Stay tuned for more advanced circuits that we are going to build up in near future. And if you like the video, like it, comment on it, and do share with your fellow members for a wider reach. And stay tuned. Wish you happy learning.